Hello everyone and welcome to our webinar today on LoRaWAN Relay and Satellite. I'm joined by Dario Buma from Lacuna, who is going to present how well made are one for each other the LoRaWAN Relay specification and satellite communication, and how we can combine the two in order to enable connectivity in areas where normal internet is not available. I'm going to now give the floor to Dario.
Okay, well, hello, that's me, Dario from Lacuna Space. I will be doing the talk for today, most of it. Adrian is there maybe to fill in and help with the Q&A. And I'm happy that you join us. Put the first slide on and dive in, because there's some information there we can share. First, a quick overview of what we want to do. A quick introduction to Lacuna. I think many people in the LoRa ecosystem already know us. I'm a little bit less known, but been around also for some time. And then an overview of what the LoRa Relay is and does. It is a specification. It's already out there for some time, but also it's pretty new, so maybe not everybody has heard. Before we can say, of course, something about relay and satellite, I do also some little explanation on satellite LoRaWAN. It's pretty much fits in right into the ecosystem. It's like a gateway in the sky, but there are some differences that I like to mention, and then we will see what is the best of these both worlds. Some example use cases and some hands-on stuff, like how does it work and what happens in practice, and of course how you can get in touch with this technology yourself. Feel free to ask questions in between, and we'll see what we can answer in the end. And of course we also have email and follow-up later on. So let's get started. Good to say always, LoRaWAN. Lacuna is really the first company. You have more companies doing it now, but doing LoRaWAN from space. First satellite was placed in orbit. I had to look it up. It's so long time ago already. April 1st, 2019. And yeah, it wasn't a joke. It was real. It was in the document, so it's a fact. And as a matter of fact, this satellite, it's a LEO, a low orbit satellite, is already decommissioned. So it's already back, it's already burnt in the atmosphere. So these have a lifespan of 4 to 5 years, these satellites. So not many companies can say that. We have offices in UK and in the Netherlands, and distributed people over the globe. So we have some presence in Brazil, Germany. It's expanding. I'm the product manager. I've been active with Lacuna since 2019, and maybe a bit before. If you look in the bottom here, we have the telex. I did this telex demo for our CTO. This is how I got involved with Lacuna. And we did this demo on the first Things conference in 2017. So that was fun. This is my connection with Lacuna, and I've been working with them ever since. And it's a good experience. Lots of stuff happening. So on to LoRaWAN Relay. For the people that don't know and the people that do know, it is a specification, just like there's the LoRaWAN class, the LoRaWAN 1.04 or the 1.03 specification. There's the relay specification, and the interesting thing about this specification that it's not a new protocol, or yeah, it is a new protocol, but it's an add-on to the existing LoRaWAN. And this is, if you start developing, you also see this is really something you add on top of what is already there, and it gives interesting possibilities. It has been published for a while, so it was first published in September 22. Then there was no software available. I will go into a little bit into that as well. But now there's also a reference implementation there from Semtech. The spec is publicly available, so you can develop, you can download, you don't have to pay. And what is Relay really about? It's about extending the range. So if you look at the picture in the right, in the corner, in certain occasions, you have end devices and LoRa is really long range, but then there's always the case that this one device, you just cannot reach it, or it's just in a place inside where you have to deploy an extra gateway or have to do a lot of investment to reach this one extra device or one or two extra devices. In this situation, this is where relay comes in. Relay really extends the range by doing an extra hop. So I have a standard LoRaWAN device with this new protocol on it, and this standard LoRaWAN device can then reach out to a next device and receive data from that device and push it to the gateway for this device. It's a single extra hop. So it's not like a mesh network, it's a single hop. Interesting is it's bidirectional, and the most important over here is it's low power. So it's a sort of a low power, it's not really a gateway, but it is sort of a gateway. So it's interesting thing. How does it work? LoRa devices, IoT devices, everybody knows that they are sleepy devices. They are supposed to sleep most of the time because they're usually battery powered, and they have to be very they are on a very tight power budget. So the radio is when the radio is turned on, they consume 1,000 times more power than when the radio is off. So you can expect, if you run for a year on the battery, hypothetical for a year on the battery with the power transmit on, you have a big battery then, you would run 1,000 years without a battery. So that's a huge gain. So how do we make this device? What is the problem that you cannot use? Why you couldn't do this with an ordinary device? Because you never know when this other sensor device is gonna send data. So basically, you would always have to listen to know to catch the data. So when they did a smart thing, they invented the wake on radio protocol. So what happens is, for the relay, and this could be a sensor that is battery powered, it's very power efficient. It listens for a few milliseconds every second, so it's very power efficient, and it gets woken up by the sensor. So the sensor, before it sends its actual LoRaWAN message, because it's a standard class A LoRaWAN message, it sends a so-called preamble, and this preamble takes for about is about a second long, and when this during this when the radio or the sensor, the relay device, where it's difficult, relay device wakes up for these couple of milliseconds and starts listening, it hears this radio signal and says, "Hey, something's going on the radio. Now I have to be a little bit more awake." Then it waits for this wake on radio preamble thing. We go to the next slide. This preamble frame, and when this frame is detected, then in this frame there is the frequency. It says like, hey, some transmission is coming up. So first it is some noise on the radio. It says, oh, something's going on. Then it wakes up more, and then it listens to this warframe, and then in this warframe it says like, watch out, relay, class A message is coming up on this frequency. And then the device is fully listening, receives this message, and then it's business as usual. This message is rewrapped in another package, and this relay device just gets everything it received, puts it in a frame, and sends it on to the gateway. And the gateway will figure out what it is. And how does the gateway know that it's a rewrapped or a repackaged message? It's because it's on a specific port. It's on 226. So once the message shows up in the backend, the LoRa network stack, in this case we use the things stack, it sees, hey, message comes in on port 226. This is a relayed message, so this is a message in a message. And what happens is that the stack then magically gets this message, unwraps it, and puts it in as if it came from a relay again, and then magically the relay device appears, or the data from the relay appears. The reality, the way I explained the protocol, these are the high lines. The reality is more complex. All the details are, of course, in the specification. So in reality, we also have a two-way, and you can do a join, and this is only full compliant, but we for satellite we don't need that, but because a satellite is uplink only. I say something about the predominant mode is uplink only. Yeah. Next, intermezzo. So a little bit about satellite. So that was about relay. What does relay? What does the satellite do? We as Lacuna have satellites in orbit, and what do these satellites? They are, very simply said, they are gateways in the sky. And these gateways in the sky, they receive messages just like you would receive them from a normal relay or a normal sensor device. The only thing, it's not something that is mounted on a pole. It's something that's floating in the space. Maybe Anastasia can quickly switch, that people have an idea. I think most people. This is a device, a LS300 device that you can use to send to the satellite. It's normal standard LoRaWAN hardware. It just has this special antenna that allows you to go up. But the rest of it, the rest of the ecosystem is, or the rest of the ecosystem infrastructure is pretty much the same. So explaining that, same. So the hardware is the same. The power you use is the same. So it will last the same amount of time as a normal LoRaWAN device on batteries. The frequencies used are the same. I put a little asterisk over there because we also have something called S-band. And the S-band I will explain a little bit later on. It has the same battery life. It uses the same infrastructure. So anything you send to the satellite, you pick it up in the back end of things industry at the same time, at the same in the same way. So your data will just appear as if it came through a local gateway. There are some differences, of course. The antenna, because we need an antenna with a little bit of gain towards the sky. There is or can be a considerably higher latency, because these satellites are low orbit. They pass around, so they're not. It's a gateway that's not always available, and it's uplink only. So you can only send to the satellite. You cannot. We do send data down, but that's more service data. You cannot individually address or confirm packets. So anything you set, it is best sent. It's best effort. So the difficulty here is the gateway is not always there, and the sensor needs to be outside. It needs to see the satellite. Otherwise, you cannot use this indoor, because the range we have to cover, or the distance we have to cover, it's too far. Why were the asterisks here? Because we also have S-band. This is same technology, same stuff, same power, everything again, but in S-band, we operate in licensed spectrum. So we have a partner which we work that has an S-band satellite, and we can deploy our Lacuna infrastructure, and we have deployed that on this satellite. And for this satellite, we have no latency. So you can send something, and it will instantly appear in the backend like you have with a normal relay. But also for this satellite, the gateway is not always there. It has different characteristics, because these satellites, they are in I think 10,000 kilometers. So you have a very long window to send your messages. But for the SRD satellites, the low elevation or the low orbit satellites, they have only a window of 3 minutes. So that's a little bit fuzzy what's going on with the satellite. Going back to the relay again. Lacuna satellite and service and relay, if you combine them, you get a one-way service. But what you get is a box, and maybe we go back to the box again, with it's lightweight, with with a backhaul in it. So I have a device that is battery powered. It can receive data from other devices and do it and send it to the satellite. And it has the potential to do multi-year battery. So this sort of makes a simplified gateway. The difficulty is, of course, it's uplink only. Other difficulties that duty cycle limits might apply. So a normal gateway, it is hooked up via internet, so it can send as much data to the backend as it wants. This kind of gateway, if you use LoRaWAN backhaul, and that's what we use for S-band, there's no duty cycle limit, for example. Or if you're in FCC region, then there's dwell time. That's also less limiting. So there is some limitations, but there's some very interesting use case where you have a very simple battery-powered gateway that has multi-year in potential battery life. Problem we have, and that's why we also do this relay, is that there are not so many relay capable sensors out there yet. So we have a device that does relay. So if you have a sensor that can do it, it will work, or at least we've tested it against our own software and that works. So now we're looking for companies that are interested in making their devices relay capable. And again, this is not the Lacuna standard. This will work for any LoRa device. So that's what's going on. So some interesting use cases you get. So this expands the market opportunity to remote places where where it's hard to install infrastructure. You can imagine that if you have to, in the middle of nowhere, and you have to put up a gateway, you either have to put up solar panels, batteries if there's no power, and this makes the complexity of such a gateway more difficult. You also probably in a remote location you need to backhaul, probably with Inmarsat or an existing location, and that also increased the cost. This is all LoRa based. It's in the same order of magnitude of pricing of devices. And sorry, there's a kid here. Go away, please. There is, sorry, I got disrupted by my son. He wanted to have potato chips. This device is battery powered. So the complexity for having this gateway, it's much. It's not a real gateway, but it has a lot of potential. Is much lower. So you can put this in the field and it will run, and it will run on batteries. And if it's end of life, you remove it and you put another one there, and it's almost instantly installed. Maybe you have to fix it on a pole, but that's a good. Also, it allows you to. We see sometimes a hurdle. You can also say, if it's LoRaWAN, why wouldn't you put this antenna inside your existing LoRaWAN product? You can also do that. I don't know if I have an antenna lying around, but you can have a separate antenna, and this separate antenna you just plug it on and you can go to the satellite as well. We would really encourage that, but we see for some companies that's a hurdle still. With the Lacuna relay in between, you could do a software update only. So this relay protocol, it's really about updating the software, and through a software update, your device becomes, or your sensor device becomes relay capable. And then with the software update, it can send to the satellite, to these low cost, or this device is called LS300 devices. It's also a use case that we see interest is coming from improving indoor penetration. Water meter companies are, for example, we've been approached by those that say, yeah, we have some wells, or the water meter isn't easily reached, and you have less dense deployments, like you are in an outside area and you have a couple of houses, but it's too expensive to install a gateway. In this case, you have a lower cost alternative for that. A little bit hands-on. So there we go again. There's the box. We have this is the standard hardware. We sell these kits, and this is just added as a software feature for us as well. So before we had the sensor application, and this application allows you to test with the network and do message and that sort of thing. Now this sensor application has the possibility, we increase or add the possibility to do relay. It's all configurable, so you don't need to do code. There's pre-configured. It's like AT command set. You configure it for which country, for which interval, which devices are allowed, and you're in business. Receive messages are automatically then queued. So every time you send a message from a relay from a relay sensor device, it gets in the queue. And when a satellite passes, this message will be sent to the satellite. Interesting to know also is that we go a little bit beyond the relay specification, because the relay specification was really about relaying, but we put in an extra delay because the satellite is not always there. So we store and forward, but this also gives the interesting situation where you can, on the one end, receive on the standard 868, and in an S-band covered area, you can uplink with S-band, and we still stay in the LoRa. So on the side of the stack, you still see the same. You don't see what's in between. You only see message gets sent, relay picks up, goes to the satellite, and the only thing you need to care about is that in the end your message ends up or shows up in the backend, and that's what we see over here. So in the ThinkStack, I wish there was more to show, but it's pretty, because it's ABP, it's uplink only. Satellite, we need to use ABP. You just configure your end device, you configure your relay device, and the ThinkStack magically takes care of anything, of any relayed message. So if a message is relayed, remember it's sent to this port 226. If the stack sees this port 226 is where the message comes from, what it does, it gets the encryption off and puts it in back in as if it came from the gateway, and in the end your data will magically appear with the correct endpoint with your device. How did we try, or how did we test this? We made an internal client, so we test with two LS300s, one with the relay, the standard thing, and the other we made some clients, and we've tested it against this, and we see very good results. I test with this myself. It's running for months, and it's good. It's low power. So we are sort of ready to take the next step, and we would love to see interoperability and work on interoperability. So people who want to get hands-on, you could also already start with, there's some links later on. You can already start with the software that's out there. So Semtech has already published, I think it was half a year later than the publication of the specification itself, but there's an implementation of the LoRa relay specification where you have a client that sends according to this protocol, and that should work. I have to be honest and say that we haven't tested interoperability over there because we were not aware that this version was there. It's a little bit hidden on the Semtech GitHub, so you have to select a specific version, but it's in the sheets later on. And also what Semtech said is that they're working on a new stack, a modem E stack. Modem E is something that runs on the LR1121 chip, and it's a complete LoRa stack that's in there. So you have a chip with that you can just talk to via API or AT command set, and this also already contains the relay functionality. So it's already there, and I know that some vendors, for example, Murata, is working on that and to get a module out. I think it's going to be there around Things conference. So what is the story? We hope that everybody sees that this is a good time to get on board to do relay integration and add this capability in your own devices. And remember, this is not only for satellite. This is adding functionality to any existing device, and this will improve the reach and the thing. So this is not specifically about Lacuna or the satellite. This is a common standard, and we make use of this standard. if you are genuinely interested to test with your own hardware, so you have a sensor, we're really open to that, and want to try to see if it works with our solution, then we're open to that. So please reach out to us via Get Me Started. There's the info. I think this will be online, so it has been in the picture long enough to copy paste. Here's the useful links, and I think I'm almost running out of time, and I'm a little bit disappointed because I'm missing one sheet somehow, and this was what has Lacuna been up to. We have been out there for a long time, and sometimes it's a bit quiet, but a lot of stuff is going on in the back. So I had a sheet on that, but it's somehow I removed it. I don't know. What we've been doing is a lot of regulatory stuff. So we are trying to get formal approval in countries, so we can officially do. Technically, it works. We've shown that. We've seen that. But now the hard part, of course, starts. If you want to put your device outside, again, you need the certification. If you really want to do something with it, we still, I think, also know the story from the guys from Things Industries. When they wanted to do a gateway, then you have to take these hurdles, and that's the stuff we're working on. We're also working on monitoring our service, so we have deployed in the meantime, this is not on our website or so, all over the globe we have monitoring stations, so we can proactively monitor our service, so we know that the service is down before our customers do. So we are building over there, and of course what you see happening over here is the relay, and that's what you see on the outside world. So lots of stuff is happening, and I'm very happy to take questions, and thank you all for participating. And sorry for being a bit chaotic, maybe sometimes, but that's the way I am. I think. Hello.
Hello. It went great.
Stop sharing.
I would say we have it went quite well. Also, lots of details, and we already have a couple of questions.
Okay.
So the first question comes from Scott Chapman. Can currently available LS300 units be configured for the US 915 frequency plan or other band?
Yes. We have two versions of the device, and the difference. So these devices, the LS300, there is an ETSI certified, or the stamp, so the UXA and the CE mark, and we have FCC version. And the difference in this device is only thing that's different is the antenna tuning. So the one antenna is tuned for the 868, and the other one is for 915. And for the rest, the devices are identical. And we have certification as well for these devices. So these are certified for FCC, the main certification, and certified in ETSI CE. And we also have specific certification for Mexico, Anatel. I don't know. There's a number of countries on the list where we have done the paperwork as well already, and we're working on that. I see one that I want to pick up. It's important for me because it was on the sheet that's missing. Are you planning to launch satellites? And that's of course one of the big things we're working on. Yes. We have 6 more satellites planned for launch, and these launches are planned somewhere in 2025, and this will be a new improved generation. So every lesson we learned with the deorbiting and with the satellites we've tested with LS1. People involved early know the LS1. It's one of my favorites. It's how I got into this direct-to-satellite arena. It's already deorbited, but we learn lessons from that, and these lessons are involved. So this is maturing. I think this is already the 3rd generation that we shoot out there. So there's 6 launches planned for I think it's 2025 the first, and then over a period of a year or 1.5 years. That's what a lot of the team is working on now, on preparing this and getting this ready.
Great. Going back a bit, so there is a question: what is the latency time? I'll I'll give half of an answer and then you can continue there a bit. So the general unidirectional latency in relay, it's about 200 milliseconds. So let's say that at the beginning, at t equals 0, when the device which is out of range for a gateway sends, that's t equals 0. The message is going to be received by the relay, and that is basically the amount of time. It depends on the time on air, so how long the message is and what the modulation is. So let's say at high spreading factor, something like 500 milliseconds. And then the relay itself will send it either to a gateway or in this case to satellite after a fixed amount of 200 milliseconds. Now that's, let's say, the standard relay latency. So let's say in the range of 200 millisecond, let's say 500 to 1 second of delay. And in the case of Lacuna, how long usually does it take until you can forward the messages to the satellite?
That depends on the for the standard LoRa satellites. The S-band satellite is the 10,000 kilometer satellite. That's one thing, but the unlicensed spectrum, the low orbit satellites, the latency is determined by the satellite path. So your device is transmitting when the satellite passes, we receive it, and then the satellite has to pass over ground station again, and then the data is downlinked. So that might be up to, I think, 24 hours that it can take. With our next generation of satellites, this will be improved because there will be more ground stations. We have another agreement, I think, with the people downlinking the data, so that will be improved over there. But that's not the latency in milliseconds, but more calculated in multiples of hours. For S-band, it's another story. S-band works with the so-called band pipe. So you send up, it's like bounced like with a mirror down, and we decode on the ground. And I think it's amazing that we can deploy the same technology in a completely different way. So I'm amazed by our tech team always with their magic, just like you do I just throw in the message and it magically appears. So for S-band, we are typically in the seconds range. So what you send is a couple of seconds later, it will show up in the things backend, in the things stack.
Okay, great. I will skip a small question. Maybe we'll come back to it at the end regarding the battery lifetime. We'll visit that again at the end.
Maybe
and the
Duarte for the ASICs chips or.
Yeah, so a bit back, and we'll do also that one regarding which chips are compatible. The short answer is that more or less all of them. How many buffered messages can be sent at each opportunity when the satellite is visible? And
that depends again. This is limited by the region, so we are bound by the same limits as standard LoRaWAN. So in a 868 region in Europe, you're bound by duty cycle, and in the duty cycle, it says you can do, I think, about 3 messages in a period. And since these periods for these satellites, LEO satellite, is only 3 minutes, we can do 3 minutes in the pass. And this is because of duty cycle limits. If there's no duty cycle limit, then you can do more. Then calculate, you can send messages back to back. If you look at S-band, that's licensed spectrum. There you can just keep on sending messages. Then you do, I think, sending a message is 1 to 3 seconds, and then you can really send back to back. You can keep on sending. So it depends on location, infrastructure.
Great. Then a follow-up question, since we already mentioned S-band. Which satellites are using for S-band such that our viewers can look up if they have coverage or not?
It's not so much these satellites. They are, even if they're medium orbit at 10,000 kilometers, they're not GEO satellites. GEO is in a fixed location, and it will always have its beam. These satellites will always also orbit, but the orbit is much slower. It's remote, so they have global coverage. However, it's licensed, and our partner operating the satellite doesn't have license global. So technically, it should work globally, but the license is available in specific countries. I have to get the sale, but the main targets are Latin America. I know we do service in Brazil, Mexico, Panama, that area. We're looking for Australia. I don't know if the license is complete there, but we are targeting there. Africa is on the radar. I think this is our partner Omnispace. They also recently launched a press release on this. They are working with an operator, MTN, and this operator is then going to resell the Lacuna technology. So it's, I would say, Latin America, Africa, Australia. And it's not a technical limitation. It's more like, where do they hold the license?
Great, thank you. Let's pick up the question regarding the relay compatibility. So we have this question. So we are still using the 1260 generation of chips, and this relay protocol can be done solely through a software update. The short answer is yes. So the firmware which Dario has mentioned, the LoRa Basics modem from Semtech, which is publicly available via GitHub, is already compatible with 1260 chips out of the box. It's a beta, but it's already available. All that you have to do is to start using LoRa Basics modem. And even the 1270, the very old ones, are supported, although that one is more... you would have to do a bit more work in order to have it working. But in short, all of the LoRaWAN transmitters, so both 1260, 1270, and 1280 are supported, but you need only a firmware upgrade for it.
Yeah, and LR11X also.
Also
Because
those,
they
yes.
are based on the same core, and you would be able to do it with the STM WL55 as well. So anything that is, has the SX1262 core will be good. And the older chips, like Adrian said, it is possible, but it's not optimal.
Yeah. The next question is, what is the satellite deployment roadmap, and when to expect that full service will be available commercially?
This is also something that is difficult to answer in a generic way. So we can look at that in a country by country basis. So we have these two technologies that are from a device perspective, customer perspective, you just say send message and Lacuna handles it. If there's a S-band satellite, you use that. If there's SRD satellite, you use that. So in some countries we have a better or faster road to get SRD approval or regulator, and in other countries it's gonna be S-band. And also the amount of messages you can send is different, of course, for S-band, which is unlicensed, against that or licensed, and the SRD, which is unlicensed. So there's differences. So there's not a generic answer, but if you want the details, I say reach out to the same email address, not with the relay heading, but maybe ask for commercial deployment. So we will be able to answer that on a country by country basis. And we are also in some countries looking for partners, because that's what the regulator sometimes wants. They ask us, like, you can get started, but we first want to see who you're gonna work with, and there's a chicken egg. So we are very open for cooperation in certain countries. In Europe, we're pretty much covered, but some very specific African countries, we are doing local partnerships, for example.
Great. I'll finally pick up the battery lifetime question.
Mm-hmm.
So we'll do it again in two passes. First, generic, and then a bit more satellite-y. So in general, when you add relay to an existing LoRaWAN devices, there is an extra transmission and receive window done for that wake on radio that Dario mentioned. However, these are very short transmission and short spreading factors, and they don't add a lot of power use, let's say. The principal transmission, the one which will actually contain the payload, will still be the main driver of battery use. So that's, let's say, on the sender side, it's going to be very comparable with already existing devices when it comes to battery lifetime. And now the specific Lacuna question is if you have any data on your particular relay to satellite device, battery wise, if you have any idea for how long can it operate, or if you've done any measurements.
Well, I should be in politics. There's a generic. No. The answer is that for the satellite transmission, it's just like any other LoRa device. We don't use more output power. We the main the main thing is that the sleep current, and the sleep current for our LS300 device, I think it is 13.5 microamps. So that's the sleep current, and the rest of it, relay, anything that you read on LoRa applies to the LS300 or the Lacuna device as well. And I don't know if the device that we created, it was not 100% power optimized. So like any LoRaWAN device, you can lower, you can go to sleep current of microamps or something like that. So it's just like the sheet, same as LoRa, no different, and the same would apply for relay. And I know I couldn't find it, but there is information out there from Semtech, I think, on how much power this wake up or this cut periodicity, and that what is the impact of that. There is information on there on the internet on that.
Great. A question from the audience: how can I get an LS300 modem in order to use with Lacuna satellites?
That's a good one. You reach out to Lacuna again to get me started, and maybe put a good subject in the heading, like I want to buy LS300. I know we have these units available. And again, I say it only makes sense to get the device if you're also allowed to operate in the countries, but there's many countries. So I would say reach out to us, and we're ready. We're ready to go and to support you. Yeah, I can go talk on, because I focus on a very small part. But what we do, we have open source libraries. The software is there, so we try to make life easy to get onboarded and to adhere to the standards and to be part of the ecosystem, because we know. This is a satellite. It's traditional. It's a vertical. You do everything yourself. But the approach of Lacuna is to go LoRa, horizontal. So we rely on you guys from things industries. We rely on device makers, and yeah, we need each other to get this to work.
Great. Yeah, so there is a technical question regarding how do you control the transmission windows according to the satellite pass. Basically, how do you decide that you need to start transmitting to the satellite as the relay?
Yes, because this was relay seminar, I didn't go very much into detail, but everything is standard about what we do on the satellite. We demonstrate this on Things conference. So the LoRa part, if you have a LoRa stack that does LR FHSS, and for example, Murata, we demonstrated with their 1SJ device, they had a stack and that does LR FHSS, and you can send to the satellite. So that's the transmission part. Now comes indeed the timing, and the timing, we have a calculation software for that, a library, free of charge. It's available, open source. You can use it, and you can use this library to make the calculation. And the principle behind it is, it's like knowing where a satellite is like forecasting the weather. You can forecast for a week or 2 weeks, but if you need new information to make the forecast. So we can forecast for about 2 weeks, and then we need new information on the satellite, because then you're farther off. Maybe then you start transmitting 10 seconds too late or 20 seconds too early. So we receive from the satellite almanac information. This information is processed by this library, and this library will tell you just tell it like, this is my location and this is the time. And then the library will tell you, oh, you have to use this modulation and you have to send at that moment. And that's what the library does for you. And if you use the standard software we have, it's just hooking it up and telling the software send message. It puts it in the queue and the satellite passes and the message goes. That's it.
Great, great. I believe you also answered the question. So the follow-up question is the relay uplink modulated in LoRa or using LRFHSS? So the relay to satellite communications is LRFHSS, right?
All satellite, everything we do towards the satellite, it's LRFHSS. The Almanac downlinks are CSS. That's downlink from the Almanac, but it's not specific device. It's like a broadcast. That's a standard LoRa, and anything we do, because the LS300 can also do terrestrial. That is chirp spectrum. We did not include it, but you could also go with this one to a normal terrestrial gateway. So this device could also be a fully relay compatible sensor device, but we didn't focus on that. We are not running the stack for this, but you could do it.
Great, great. It's an interesting question coming up due to the difference in latency, basically the latency introduced by the delay of the satellite. Is it possible that the messages arrive in a different order, basically to the ground stations and also, let's say, on the network server side?
Yes, that's definitely the case. What you see is when you send the messages, if there's for example, I'm in an S-band pass, I send messages, or I'm in an SRD pass, I send a message, and the next message I send via S-band, and then a message again via SRD, then you know for sure that the S-band message will be there sooner, because the other ones will take hours. And I know that this can pose problems for some stacks, and we are discussing with industry parties to see how we can arrange that. Because what we now do is just mark the receive out of order, but then you also would lose your replay attack. So there's a specific network attack you could do, and we need some window where we can have out of order. And now the LoRaWAN spec, it's like, if it's out of order, if you receive 1 and then you receive 8 and then you receive 7, then it's not okay. And we need something that is a little bit of a window, because in the worst case it takes 24 hours, and in the best case, and these devices don't, because it's satellite and remote, we don't send thousands of packets in a minute. So the counts will be always somewhere in the 10 range, something like that. But it's a good question, and it's something we are actively working on.
Great, great. The follow-up question is, which LEO satellites are listening for relay uplinks, and what kind of frequencies do they monitor? Do they monitor all of the possible LRFHSS frequencies, or are they region specific?
This is the satellites. That's maybe a good one to mention. It's not relay specific. So you just send a message, and if it comes through relay, it doesn't matter so much. It's just a message from a device to the satellite. So if it's a relay message, or just like we don't care if it's a water sensor or temperature sensor, or it's data. The satellites, the SRD satellites, operate in the same frequency range as you would do in a normal country. So that's the proposition of Lacuna. You can send to a local gateway, or you can use the same. So in Europe, if the satellite's over Europe, we listen on 868, and if the satellite is in Latin America, passing in Latin America, we listen on 915. That's what's happening, and it always makes use of this LRFHSS. And for S-band, it is slightly different. There's also a range where it listens, but this is all how do you say it? This is all hidden, or not hidden, but this is all being dealt with by the software. The software, you just tell it like, I'm here, send this data, and it will time and tell you figure out the frequency and that sort of stuff. And this software is freely available. It's open source.
Great.
There was a good question there. The firmware is not available on GitHub, and that's not that it is under NDA or it is not allowed to share it, but that's the support pressure we get. So as soon as we put it out in the open, then we get a lot of questions. So what we do is when you order a device, LS300 device, then we enable you and give you access to this software. And you're of course free to share or approach to somebody that already has access and get the software, because there is, I think it's a standard BSD license that's on it. So there's nothing fancy or you have to sign contracts. It's there, but the access is, it only makes sense to use that when you have one of these. So we connect it, but maybe later on it will be on GitHub. We'll see when that opportunity arises.
Great. I believe we went through all of the questions so far. There is one specific one regarding an email you can use to reach Lacuna on. We are currently posting the contact details again in the chat, and you will have access to the recording of this video as well, to go again through the slides and also the contact links and everything. We are currently waiting if there are more questions. Otherwise, in about a minute, we will slowly close up.
Yep. Important when you reach out via the Get Me Started, put in the subject. We get a lot of email, also spam when you have a thing. So if you have a good subject, it's easier for us to direct the email to the correct person and departments. But really appreciate it to do this. We're also looking forward, of course, to Things Conference. Maybe I can do some promotion over there already. Yeah, we're hoping to do something with Relay over here. So the challenge really is there. If there's people out there that have Relay the capable device, and we know there should be some, please reach out, because this is all about interoperability, and showing interoperability, then we can have the building blocks doing stuff together. Because having just the connectivity without the sensor, there's limited value in that, but if you connect it to, there's opportunity. So we're really looking out for being in contact.
Great. Thank you. So we didn't have any new questions. I believe we walked through everything. Otherwise, please reach out by email. We've posted all of the contact information, and as I said, the video will be available again. Thank you very much, Dario, for the webinar. Thanks to all of you for attending. And
thank you, Adrian, and Anastasia in the back for your good support and help, and appreciate it.
Yeah.
And thanks
Have
for
a great
watching.
day, everyone.